Hi dear students, today I am going to explain probability 2 marks questions part 1 under term 2. This is the most important ones I am going to cover. The coming 2 weeks I will cover all the important questions. Now the first of class today I am taking probability 2 marks questions under part 1. So these are the 9 questions, most important one, 9 expected questions. So these are the most 9 expected probability 2 marks questions part 1 I am doing today. 9 maximum possible expected questions this one. Tomorrow's session I will do one more session for part 2, 2 marks questions only. These are all important questions that I am going to cover. Definitely if we solve this, maximum chances are there to improve your score, no doubt in that. If you follow me, definitely you can score maximum. You can maximize your score. You can maximize your score now. I hope these are the 9 questions, selected questions. Now one after one I will explain to you all the 9 questions. It takes maximum of 30 minutes to complete this session. Now see the first session now. The first problem you can see here. Coming to the first problem, they are given A and B are 2 candidates seeking admission in a college. The probability that A is selected is 0.7 and probability that exactly one of them is selected is 0.6. Find the probability that B is selected. Find the probability that B is selected. The first one, this is the problem I am going to explain. One after one, I will explain all this. See, they are given here. See the answer now. A and B, they given A and B are 2 candidates admission to college. The probability that A is selected is 0.7. They are asking the probability exactly one of them is 0.6. Probability of A they are given. P of A is given. When P of A is given, you can see this P of A is given, which is equal to 0.6. P of A is given. They are asking find probability that B is selected. What is the probability of B? They are asking. What is the probability of B? But you can see here in this, when they are given this one, see P of A we know 0.6 and P of B is equal to this. What P of B? But they are given here probability that exactly one of them is selected. So when they are talking exactly one of them is selected means the meaning P of A intersection B dash, because when A is selected B should not select, plus P of A complement intersection B. So this they are given. Exactly one of them is selected means when A is selected B should not select. When A is not selected B should select is equal to 0.6. This they are given. So this value is given. This value is given. Now from this should find P of B. But these events are independent. Since events are independent, I can write P of A into P of B dash. So whenever 2 events are independent, we know that P of A intersection is P of A and P of B. Since these 2 are independent events, I can write P of A into P of B dash plus P of A dash into P of B, which is equal to 0.6. But we know P of A equal to given 0. So this one you can see. Oh sorry, this is P of A is given 0.7, not 0.6. Should be careful here. Sometimes you may do the mistake, you should be careful. They are given this value is 0.7 is given. So P of A is 0.7. P of B dash. So P of B dash, this one we can write 1 minus P of B. P of A dash. P of A 0.7. P of A dash 1 minus P of A. P of B is required one. P of B equal to 0.6. Now this is 0. You can see here, this I can write here. This is 0.7 into 1 minus P of B is required. You can write 1 minus P of B plus 1 minus P of A 0.7 into P of B equal to 0.6. Now you can simplify here. This one 0.7 into 0.7. Just you simplify the value now. So we can take it P of B common here. You can see 1 minus 0.7 minus P of B. This is 1 minus 0.3 P of B. This if we expand 0.7 minus 0.7 into P of B. P of B. 1 minus 0.7 is 0.3 into P of B equal to 0.6. Now you can see here. I can transfer P of B one side. 0.7 minus 0.6. You can transfer this side. Minus 0.7, 0.3. It will be 0.4 into P of B. Right. You can see the value if we simplify. The final one I can write. So I can write here P of 0.7, 0.6, 0.1 equal to 0.4 into P of B. So you can see which is nothing but I can write P of B is equal to 0.1 by 0.4. It will be 0.1 by 0.4. It will be 1 by 4. That will be our answer. 0.1 by 0.4. We got the answer right. This is 0.4. 1 by 4. I hope you understood this right. You can write here. See, P of B is equal to 0.1 by 0.4. That will be 1 by 4. That is the required answer. That is probability of B. This is important model. Next, you can do the next problem. You can see now. I hope it's clear. Anyone have doubt in the chat box, you can ask me. I can explain again. If you have doubt, I can explain again. I hope it's clear, right? Anyone have doubt the first problem, you can ask me in the chat box. I can repeat, I can explain again. I think it's clear. Let me share your views in the whether you understood or not in the chat box. Then I can repeat if it is required. Okay, I think it's clear, right? Now we do the next problem now. See the next problem now. Two dice are thrown together. Let A be the event getting 6 on the first die and B be the event getting 2 on the second die. Are the events A and B independent? Remember, when they're talking about events, are the events A and B independent means what you should prove? P of A intersection B equal to P of A into P of B. If we prove this, the events are independent. The result is, if we prove this, the events are independent. Two dice are thrown together. A be the event getting 6 on the first die. So 6 on the first die, you can think about that. A is equal to, they are talking about 6 on the first die. 6 on the first die means you can write 6 1, the possibility, comma 6 2, 6 2, 6 3, correct, 6 3, 6 4, 6 4, comma 6 5, 6 5, and comma 6, comma 6. So this is the, they're saying here, A is the event getting 6 on the first die. 6 on the first die. B is getting 2 on the second die. 2 on the second die. So B is equal to 2 on the second die means I can write 1 2. 2, 2, 3, 2, we can write 3, 2, 4, 2, I can write 5, 2, 6, 2 we can write, correct? Like this, okay, this is B is the event. So what about A intersection B here? You can see what is A intersection. In this you can find what is A intersection B. If we take A intersection B, the common events of both, the common event only it comes here. So you can see 6, 2 is the common event. 6 comma 2, only one event. This 6 comma 2 is the common. So you think what is the probability of P of A? You can think about what is the probability of P of A. When I have taken probability of, you can see here, I can find the probability of P of A. Right. So what is the probability of P of A? You can find probability of P of A. When you have taken the probability of P of A, see when is the probability of P of A, if we consider, see what is the probability of P of A comes. So A means total 6 we have. So what is the sample points? 2 dice are thrown, 6 into 6, 36, right? It will be 1 by 6 probability of A. Similarly, what is the probability of B? Probability of B. This is also the same thing, probability of B. So B is getting the second on the die. 2 on the second on the die, right? Here also it comes probability of B also will get 1 by 6. P of A 1 by 6, P of B 1 by 6. Right. Similarly, what is the P of A intersection B? Common, only one event. So P of A intersection B, favorable event only one. 1 by 6 into 6, 36. 2 dice are thrown, right? We got like this. You can verify what is P of A into P of B. Verify P of A into P of B. 1 by 6 into 1 by 6. 1 by 36. So our conclusion is P of A intersection B equal to P of A into P of B. We got P of A intersection P of A into P of B. So we got which is equal to P of A intersection B. Therefore the given events are independent. A comma B are independent. The conclusion I can write. A comma B are independent, we can write. A comma B are independent events. A comma B are independent events. So we can write A comma B are independent events. A comma B are independent events. This are A comma B are independent. These two are independent. They are asking independent. Independent means P of A intersection P of A into P of B. I hope you understood this. If you have doubt, you can ask me. I can explain again. Is it clear? My dear students, is it clear? Yeah, understood. Then I can do the third problem now. See the third, when I am going to the third problem here, these are related to 100% of the bulbs. 100% of the bulbs produced in a factory are of red color. This is the third problem. I would explain the third problem now. This is one of the important model. You can see now. Right. So the given. This is 10% of the bulbs produced in a factory are of red color and 2% are red and defective. If one bulb is picked up at random, determine the probability of its being defective, if it is red. Find the probability of it defective, it is red. So then there is the given here, 10% of the bulbs produced in the factory are of red color and 2% are red and defective. Are of red color and 2% are red and defective. If one bulb is picked at random, determine the probability of being defective if it is red. So we have defective, not defective. Two cases we have. So you can consider A and B be the events that both bulb is red and defective. You can consider bulb is red and defective. We can consider here. I can consider A and B be the events A comma B be the events. A comma B be the events. I can consider events that the bulb is red, that the bulb is red and defective respectively. Defective respectively. I have taken A comma B be the events that the bulb is red and defective respectively. You can consider like this, right? So I have taken this, that the bulb is red and defective respectively I have taken. So what is the probability of P of A? You can think probability of P of A. 10% of the bulb produce a factor R of red color. So probability of selecting red color 10 by 100. And why by 10% of the bulbs produce a factor R of red color. So the probability of a red color bulb will be 10 by 100. That will be 1 by 10. And next, the saying here that should be defective means probability of A intersection B. The red bulb which is defective will be 2%. 2% will be defective. 2 by 100. 1 by 50. This is given right. 2 by 100. So now what they are asking here, determine the probability of its being defective if it is red. Defective it is, you should find conditional probability P of B by A. They are asking to find probability of B by A. You should find probability of P by A. I can find P of B by A. Correct. Why? Because when it is red, given it is red, that should be defective. So that means P of A intersection B by P of B. So P of A. Then I can write, we know P of A intersection B 1 by 50 by P of A will be 1 by 10. Now you simplify, it goes 1 by 5. That is the required answer, right? So the probability of if it is red means when it is red, it should be determine the probability of it being it's a defective if it is red. So P of B by A 1 by 5. So we understood this simple one. Next, this is the fourth one. Given that E and F are events such that P of A equal to 0.3 and P of B equal to 0.6, find P of A complement intersection B complement. They are asking this one. So this one you observe here, this is also a simple problem, but here this is De Morgan law. P of A complement intersection B complement. They are asking P of A complement intersection B complement. So if we take P of A intersection B complement, and also we know that this is a event such that P of A equal to 0.3 and P of B 0.6 again. Here actually we should consider they are given 0.3, 0.6, 0.3, 0.6. So depends here. E and F are independent events if they give. Easy to solve the problem if they give independent events. Why? Because here then given that E and F are two independent events here. If we consider, given that two independent events this one. If we consider independent events, the problem is solving this one. If they are not given independent, I can P of A dash intersection B dash means you will get P of A union B whole dash. Because this will be P of A union B whole dash 1 minus P of A union B. But they are given only given E and F are, this should be here missing something here. I can write E and F are two independent events. No, they are asking P of, they mention A and P, E and F. Oh, I think this one, see here, correct. We have taken, oh, this is A and B, here this is a mistake. You can, small change we do here, given that two independent A and B are such that we can do that change here. Right. I can do here this one. Given that this is A and B, you can write are two independent events. Correct. Given that A and B are two independent events such that P of A equal to 0.3, P of B equal to 0.6, find P of A complement intersection B complement. Then this will be equal to, since are independent events, I can write this one P of A complement into P of B complement we can write. Probability of this we can write. Probability of A complement, probability of B complement we can write. This will be easy, I can write this one. P of A complement intersection P of B complement. Into P of B complement. Since these two are independent events. So I can write this is 1 minus P of A. This is 1 minus P of B. So you can write 1 minus 0.3. This is 1 minus 0.6. 1 minus 0.7 into this is 0.4. It will be 0.28. 0.28, a simple question, but you do the changes what I have done here, you can follow that. This is the fourth one, simple one. See this one now. This is the problem. Given that E and F are events such that P of E equal to 0.8, P of F is equal to 0.7, P of E intersection F equal to 0.6, P of E complement by F complement. Conditional probability of this. P of E complement by F complement. They are asking this one to find this. Check this. When they are asking here, so this is also simple one. You can think about this. When they are asking this one, I can also write this. You can see this. When they are asking this one, I can write P of E complement by F complement equal to, we know conditional probability, this one I can write P of, I can write E complement intersection F complement by P of F complement, right? Condition probability, using condition probability. This is nothing but P of union of whole dash, right? This is nothing but P of De Morgan, union of whole dash by P of F dash. But P of union F dash means we know that this is 1 minus P of E union F by 1 minus P of F. Because we know this probability is right. Now I can find here. So from this, let it be here, I can consider this is the equation 1. Now I can find P of E union F. When I am finding P of U union F, I can find this will be P of E plus P of F minus P of E intersection F. We know the values of this 0.8. So just we know the value of this. I can write here. So this is 0.8, 0.7 minus 0.6. So 1.5 minus, you can see here, I can find here 0.6. So you can see now, if you find this value, it comes 0.9. That is P of U union F. Now you can see here, from 1, I can find P of E complement by F complement, I can find now. From 1. I can find here from 1. So from 1 we can write P of E complement by F complement equal to, I can write 1 minus 0.9 by 1 minus P of F. P of F is 0.7. So it will be 1 minus 0.9. It will be 0.1 by 0.3, which is equal to 1 by 3. So that is the required answer. 1 by 3 will be the required answer. This is important with this model also. Just we do like this, P of E complement by F complement is 1 by 3. I hope you understood this. If you have doubt, if you want to repeat, you can ask me in the chat box. I can repeat any number of times. You can ask. If you are not understanding, you can ask. I can repeat this. I have completed 5 problems. Still, if you want to do any problem to repeat again, let me know in the chat box. I can repeat. Now I'm going to explain the 6th problem now. Good. I'm going to explain 6th problem now. A speaks truth is in 80% cases and B speaks truth in 90% cases. In what percentage of cases are they likely to agree with each other in stating the same fact? So A speaks truth, that means P of A, 80% of the cases. You can think when they are talking P of A. So when they are given here, see this whatever what is given here, when the value is given here, I can write P of A. P of A is equal to 80% of the cases. 80 by 100. Correct. You can simplify this. It comes 4 by 5, right? B speaks 90% cases. P of B. The probability of B. 90 by, I can write 100. Right? This will get 9 by 10. In what percentage of the cases are they likely to agree with each other in stating the same fact? Oh, they should agree. That means both should agree. So they're asking probability of both should agree, right? Probability of both agree. Whatever it may be. Either they may be speaking truth or they may be telling lie. Both should agree. They're telling both agree, right? So when they're talking both agree here, when they're talking both agree means what is the meaning of this? I can write this one. Both agree means both should accept. Both should accept and both should not accept, right? Together. Agreeing, not agree. Like they can say the meaning speaking truth, both. Or there's like they're telling lie. Speaking truth, P of A intersection B. Telling lie means this one, P if complement intersection B complement. This is a possibility. Both agree means right, both speaking truth or both telling lie. Both speaking truth or both telling lie. These are all independent events. Since independent events I can write this is P of A into P of B. I can write plus this same thing P of A complement into P of B complement we can write. We know the values of this. P of A is 4 by 5. I can find this one, you can see here. When they have written, similarly I can also find P of A is 4 by 5. 4 by 5 into P of B, 9 by 10. P of A dash 1 minus P of A, 1 minus 4 by 5 into 1 minus P of B, 1 minus 9 by 10. You can simplify this. It gives the required answer. You can check this one. It will come 36 by, it will be 50. This one, 1 minus 4 by 5, 1 by 5 into this one, 1 by 10. 1 by 10. Right. Total you can add this one, 37 by 50, right? You can see a simplification if we do now. 36 by 50, correct. You can see now. 36 by 50, 1 by 50, so 37 by 50. 37 by 50. Correct, 37 by 50, we got it. But they are asking here, see, finally they are asking, correct, they are speaking the truth. In what percentage, they are talking about in the percentage only, right? But in what percentage of cases are they likely to agree with each other in stating the same fact? They are asking the percentage. So this one in the percentage means can I multiply numerator and denominator with 2? 74 by 100. See, it's nothing but 74%, right? We're expecting the percentage, multiply numerator denominator by 2, 74 by 100, so we get 74%. So that is the required one. My dears, is it clear? I think. Any doubt you have, you can ask me. I hope you understood this. Is clear what I have explained now? Right? Simple problems concept is simple but important questions. These are the expected questions. Questions are expected questions. I hope you are good. I understood that. Now I am going to do the next one, seventh problem. I am going to explain the seventh problem now. See the seventh problem. A couple has two children. Find the probability that both are boys if it is known that one of them is a boy, the older child is a boy. A couple has two children. Find the probability that both are boys, and if it is known that one of them is a boy, the older child is a boy. They are given like this. The older child is a boy. Now you can see this in the possibility I can write here. This, just solving this one, I can find. See, they given two children for that both are boys. What is the possibility now? What is the sample space can I consider? Think about the sample space in this case. Can I consider the sample space? Both will be boys, right? I can consider both will be the boys because they given. If it is known that one of them is a boy, the older child is a boy. So I can consider what the possibility I can consider. Both the boys I can say. Both the boys are boys and girl, boy and girl. The possibility. Next, girl and boy, or both are girls. So this is the possible sample space. Correct. Now they can see here. They're saying here, it is known that one of them is a boy, the older child is a boy. So I can consider like, otherwise I can make it this is B1, B2. Because to understand this B1, this is G2, beginning right. So this is G1, B2, and I can write G1, G2. Why? Because I given the marker like this. We can write B1 is the older boy and G1 is the older girl we can consider. So we can consider B1 is the older boy and G1 is the older girl. You can consider, see, B1 is older boy and G1 will be the older. You can consider like this to understand this. Older boy and older girl you can consider. Now what is event? Both the children are boys. Event you can consider event even. Both the you can consider event even. Both the children are boys. Both are boys. Both the children are boys. Both children are E1. What about E2? E2 is one of the children is a boy. You can write one of the children is a boy. One of the children is a boy. And E3. If we take it E3, I can consider the older child is a boy. That is what they are asking. The older child is a boy. The older child is a boy. Both children are boys. E1, E2. One of the children is a boy. E3. One of the children is a boy. E2, E3. The older child is a boy. The older child is a boy. Now you can see the first one. They are asking what the first case they are asking here. Definitely they are asking one of them is a boy. One of them is a boy means what I should find here? The probability of, you can see E1 by E2. So you should find probability of E1 by E2. because one of them is one of the children is a boy. P of E1 by E2. So you will get P of E1 intersection E2 by P of E2. P of E2. Correct. P of E1 intersection E2. You can check that P of E1 intersection E2 means, so considering both children are boys and one of the children is a boy, means see the possibility we have only this one, total 4 sample points. So probability of P1 intersection E2 will be 1 by 4 by P of E2. P of E2 means, what is E2 here? One of them children is a boy. That cases we have one of the boy means you have total, you can three cases, 3 by 4. See, it will be 1 by 3. And this is 3 by 4. 1 by 3 it comes. Next one they are asking. Second case. The older child is a boy. The older child is a boy means they are asking here P of E1 by E3. Both children are boys, but the older child is a boy. So you should find P of E1 by E3. The older child is a boy, P of E1 by, similarly you do that. I can find the second one, I can find P of probability of E1 by E3. Same thing you can write P of E1 intersection E3 by P of E3. P of E1 intersection E3 by P of E3. P of E3 I can consider. Same thing, P of E1 intersection E3 we consider. So the older child is a boy, that possibility we have only 1. So 1 by 4 by P of E3. The older child is a boy means we have two possibilities, 2 by 4. 2 by 4. So now you simplify, it should be 1 by 2. Answer is 1 by 2. P of E1 intersection E3 by P of E3. This is possible, only one case 1 by 4. And this one 2 by 4. We have two cases. The older child is a boy. Two cases, 2 by 4, 1 by 2. Yes, that will be enough, right, to solve this problem. Simple 2 marks questions. I think a simple problem but important model. I hope you understood this. Can I do the 8th one now? Can I solve the 8th one? Yes. Practice these questions. I am going to explain the 8th one now. I hope you understood this. So now I am going to explain the 8th one. It takes 2 more minutes. Yes. Then fine. If A and B are two independent events, prove that A complement B and are also independent. They are asking to prove these two also independent. Again, A and B are independent events. When A and B are independent events, so what is the meaning of this? A and B are independent events means P of A intersect P of A into P of B, that we know that. I can write A comma B are independent events. The given A comma B are independent events. The given independent events I can write P of A comma B independent events I can write P of A intersection B is equal to P of A into P of B. This is given. So independent event they have given this one, right. P of A into this will be P of B. Probability this is correct. P of, because independent events I can write this one. P of A intersection B is equal to P of A into P of B. Product of this P of A into P of B. But they are asking, these are all independent, you can consider P of A complement intersection B. You can consider this one. I am going to explain this one, right. P of A complement intersection B means is nothing but this one. You can see here, this is, I can write P of B minus A. We want, you see, not A and B. This is P of B minus A. P of B minus, right. So which is nothing but P of B minus means P of B minus P of A intersection B. Correct. P of B minus A means I can consider P of B minus A means P of B minus P of A intersection B. But we know that P of A into P of A into P of B, I can write P of B minus P of A into P of B. I can consider this because they are given, these are independent events, P of A into P of B we can write. Now we can see here, what can I conclude now? From this I can take it P of B common. I can take P of B common. It will come 1 minus P of A into P of B. But we know that 1 minus P of A dash. We got P of A dash into P of B. Hence we have proved this. P of A complement intersection B equal P of A complement into P of B. Therefore, A dash and P are independent events. Therefore I can write A dash and P are independent events. And B are independently given. A dash and B are independent events. I can write this. A dash comma B are independent events. Independent events. These are all independent events. That's all. Important one. The last problem now. This one. Should I repeat any problem up to question number 8? Should I repeat any problem up to question number 8? Let me know. Should I repeat any question up to question number 8? Should I repeat means I will repeat question number 8. So with this I am going to complete the last problem. Now it takes around 2-3 minutes. I am going to complete this. I hope you understood. I think I am going to explain the 9th problem. See the 9th problem. The probability of simultaneous occurrence of at least simultaneous occurrence of at least one of two events. The simultaneous occurrence of at least one of two events A and B is P. So simultaneous occurrence means the meaning here you can observe here. Simultaneous occurrence of P is given, P is given. Simultaneous occurrence of two events is P. If the probability that exactly one of A comma B occurs is Q, one of exactly A comma B occurs Q, that is in Q. So probability of simultaneous occurrence of at least one of two events means the meaning is the given P of A union B is equal to P is given. When they are using the word at least one of two events means they are given A union B. P of A union B is given. P of A union B is given, that is P. P of A union B is given P. And if the probability exactly one of A comma B occurs is Q. Exactly one of A comma B. What do you mean exactly one of A comma B means the given exactly one of A comma B occurs. So that you can exactly one of A comma B. Only if A comes, B doesn't come, B comes, A doesn't come. Like that exactly one of A comma B occurs. One of A comma B occurs, they are given. Correct. So that I can also meaning of that. Exactly one of A comma B occurs means the meaning is P of A union B minus P of A intersection B. I can write this one. P of A union B minus P of A intersection B, which is equal to, we will get Q. This is given. Totally A into B, I am taking A intersection. What is the meaning of this? Can it, sir, can you think about this? Means exactly one of A comma B occurs means when A comes, B doesn't come, B comes, A doesn't come. Is nothing but what is the meaning of this? So P of A minus B plus P of B minus A, meaning is P of A minus B plus P of B minus A. Then that you can write P of A and B minus P of A intersection B is equal to Q is given. But we know that P of A and B is P. So P minus P of A intersection B is equal to Q. From this I can write P of A intersection B, which is equal to, I can write this one P minus Q. That will be P minus Q. Right. Now, because I am expecting P of A complement plus P of B complement, right? I got P of A intersection B, P minus Q. So from this, can I conclude this P of A intersection B? I can write 1 minus P of A intersection B whole complement equal to P minus Q. Why? Because we know P of A complement 1 minus P of A. P of A intersection will be 1 minus P of A intersection B whole complement. Apply De Morgan law. 1 minus P of this will come A complement union B complement. P of A complement union B complement equal to P minus Q. We get this one right. From this I can find P of A complement union B complement equal to 1 minus P plus Q. You trans 1 minus P plus Q, it comes right. 1 minus P plus Q. So why I have tried this? Because the required is P of A complement to P of B complement is there. So now I can expand this. P of A complement I can expand. It takes 2 minutes to complete this. Just observe here, this I can expand. This is P of A complement plus P of B complement minus I can write P of A complement intersection B complement. P of A complement intersection B complement equal to 1 minus P plus Q. This we have. Correct. I can transfer this one that side. So P of B want only which is required, I can keep left side right. I can write now. This one I can consider P of A complement plus P of B complement which is equal to 1 minus P plus Q plus P of A complement intersection B complement. P of B complement. Again, if you use De Morgan law here, I can write this at almost the end. I am going to complete 1 minus P plus Q. This one I can write 1 minus P of A union B complement. Correct. P of A union, I can write 1 minus, no, this is nothing but A complement intersection B complement. Correct. This is actually, this is A union B complement. If you want, I can write this one to understand. I can make it. What can I write here? I can write this one. Only this stuff you can see here. This will be, I can write P of A union B complement, right? So either 1 minus P plus Q. A union B complement is nothing but I can, this is P of A union B complement. 1 minus P of A union B. I can write like this. Now 1 minus P plus Q. This will be 1 minus P of A union B will be, we know A union B is the given P. 1 minus P. See, this will now finally, this will become, you can see here, this also 1 minus P. If we simplify 2 minus 2P, 1 plus 1, this will be 2 minus 2P plus Q. This is the required answer. So with this I have completed the 9th problem. So if you have any doubt, you can ask me in the 9th problem. Each and every step I explained here, these important models, explain, go through these problems. Tomorrow's session I will explain few more 2 marks questions. Tomorrow maximum another 10 to 15 questions I am going to explain 2 sessions. I will complete that. So this is a problem I explained to go through, just go through this, simplify. So So with this I have completed the session 10 problems. Then see you tomorrow. Tomorrow see you that. Tomorrow in 2 sessions I am going to complete the entire probability. One session I am trying to complete another 2 marks questions, important questions. After that I will try to complete even case study questions in probability. That is important. Tomorrow session case study questions along with these type of questions we will complete. Okay then. Good night. See you tomorrow. Yeah. Any specific problems if you want, let me know in the chat box. I can do that. If you like the session, like it, your choice. I hope you understood. See you tomorrow then.